Now let us consider a function that looks quite innocent, square root of x, and we want to discuss its derivative. If we sketch the graph, then this is the inverse function to x squared when considered for positive x only, for non-negative x only. And if we take this parabola and mirror with respect to the line y is x, we get this graph of the square root of x. We use the formula that x to n derivative is n times x to n minus 1. For a special case, n is 1/2, because square root of x is equal to x to 1/2. And then for positive x, we have that the derivative f prime is equal to n, which is 1/2, x2 minus 1/2, which can be written as 1/2 square root of x. This is perfect when x is positive. And now what about at x is 0? First, we know that square root of 0 is 0. That means the origin belongs to the graph of the function. Let us consider the two one-sided derivatives. The right-hand side derivative at 0, when computed from the definition, is limit for h approaching 0 from the right on function value at x plus h, which is 0 plus h, which is h, and the function is square root, minus function value at 0, which is 0, divided by h. We can reduce square root of h, and we have 1 over square root of h for h approaching 0 from the right. When x goes to 0 from the right, so does the square root, and 1 over a small positive number is a large negative number, so it goes to plus infinity. What about the left derivative at 0? If we consider again the definition, now the limit for h approaching 0 from the left, and here we have the same expression before, but now when h converges to 0 from the left, it's a small negative number, and square root of h has no result. So limit of something that does not exist doesn't exist either. No derivative. Well, this is easy to see from the graph. If there are no points on the left, there are no pairs, no slope, no secant, no limit, no derivative. No surprise. So to conclude, f derivative at 0 as a both-sided limit and working with real numbers does not exist. Only the right-hand side derivative exists, but is improper, is infinite.